these three types of characteristics are there. One is speed current characteristics. This is speed current characteristics. This one is speed torque characteristics, and third one is torque speed characteristics. Torque speed characteristics. These are the characteristics of shunt motor. It is applicable to series motor as well as for compound motor also. Speed current characteristics. Speed current characteristics. First one is speed current characteristics. Speed current characteristics, that is omega versus current Ia, or N versus Ia characteristics. Omega is in radian per second and N is in RPM. Now we are taking omega, that is radian per second, angular velocity, angular speed, and Ia, that is armature current. In case of motor, it is EB is equal to Zn phi by Zn phi into P by 60. A is number of parallel path in armature winding. So EB, back EMF, or in case of generator, is G, generated EMF. This depends on Z, number of conductors, N, RPM of the machine, that is the rotation, speed, phi, flux per pole, P, number of pole, and A, number of parallel path. Now in this case, N by 60, RPM by 60 will give RPS, this term, N by 60, that is equal to N or RPS, radian per second. That is radian per second, N by 60. N by 60 is radian per second. So we can replace RPM N with small n. So the equation will be Z N small n, not this one, N phi P not 60 by A. So the equation is reducing to Z N phi P by A. Now the fact is N, radian per second. N can be written as omega is equal to 2 pi m. N is in RPS, radian per second, that is number of rotation per second, and omega is radian per second. So once we convert N into omega, that is we are changing the unit, radian per second, then omega is equal to 2 pi s. So N is equal to, if we replace N in this equation, so 2 omega by 2 pi, so Z omega phi P by A 2 pi. So this is the equation EB. Now our interest is omega, that is the speed. We are going to draw speed current characteristics. So our main point of interest is omega. Now Z is a constant, Z is a constant, P is a constant, Z is constant, P is constant, 2 pi A is also constant. So all constant term Zp by 2 pi A will give a constant that is called armature constant Ka. So if we replace all constant terms with a single constant Ka, then the equation will become Ka phi omega. So EB is equal to now Ka phi omega. We are getting EB is equal to Ka phi omega. Now omega will become EB divided by Ka phi. So we are getting omega is equal to Ka by phi. That is, we are getting here. Now we know from the voltage equation, we know EB is equal to terminal voltage minus IA RA. From voltage equation of our shunt motor, we know EB is equal to Vt minus IA RA. That is, Vt is equal to EB plus IA RA. That we are writing EB as EB is equal to Vt minus IA RA. EB is equal to Vt minus IA RA. So if we replace the value of EB, in this equation, then we get, this is the value of EB, this one, EB is equal to Ka phi omega is equal to Vt minus Ia Ra. That is, we are getting Ka into phi into omega, which is the value of EB. We are replacing the value of EB with Ka phi omega in this equation, voltage equation. So from this we can write omega is equal to Vt minus Ia Ra divided by phi omega. So from here we can write Vt minus Ia Ra by phi omega. That is the equation of omega. Now we are going to draw characteristics of speed versus current, that is armature current. Now if we increase armature current, then Ia Ra in this equation, Ia Ra, this portion of the equation will increase. If we increase current from initial value 0 value to higher value, then from 0 value to higher value to rated value, towards rated value and beyond rated value, then Ia Ra will increase. So Ia Ra will increase means Vt minus Ia Ra, this term will reduce gradually with the increment of Ia. With increment of Ia Ra will increase, hence Vt minus Ia Ra, numerator, this term will decrease. So hence speed, in this equation, this is not omega, this is Ka. So if we increase Ia, then numerator will decrease. That means our omega, that is the speed of the machine, shunt motor, will decrease. In this case, when we are increasing Ia, there must have some effect of armature reaction. If we neglect armature reaction, say there is no effect of armature reaction, that is demagnetizing component of armature reaction is not present, in that case we can simply say that Vt minus Ia Ra is decreasing and phi is constant. This is speed, this is Ia armature speed omega. Now say we are increasing Ia, that means our omega is decreasing. Omega is decreasing with the increment of Ia. Now say at initially the machine is with no load, running at no load. At no load, IA, armature current of the machine, is very less, negligible. So IRA drop is negligible compared to VT or terminal voltage. So at initially when IA is approximately equal to 0, then at no load condition omega 0 at no load speed is equal to Vt by 5 Ka. That means this term is 0. So at no load our speed is omega 0, so this one is our no load speed omega 0, this term here, the speed. Now if you increase Ia, gradually, then your IARA term is increasing and Vt minus IARA is decreasing, hence your omega is decreasing. Here we are considering that phi is constant, that is there is no effect of armature reaction and as well as saturation also. So with increase in Ia, your curve will shift towards this. That means our speed will drop slightly, with the increase of Ia. Value of Ra is very less, that's why the drop is not very much, so it will shift downwards, that is current will drop slightly with increase of armature current, that is current in the machine. Now if you consider the armature reaction, this is armature reaction neglected. Here armature reaction neglected in this curve. If we consider the armature reaction again, now increasing current Ia, armature current, will increase armature flux. So effect of armature reaction, particularly demagnetizing component of armature flux, will reduce main flux phi. This one, main flux phi will be reduced. As a result, this term, whole term will increase slightly. So if we consider armature reaction, in that case the curve, actual curve will shift slight upward. So this is the with armature reaction. When armature reaction is considered, the curve is given by this one. So this is the speed current characteristics, speed armature current characteristics of a shunt motor.